What I'm going to do is our speakers come up. I'm just going to ask them to stay, then come to the panel so we can do Q&A.
So thank you very much. Pleasure to be here. Thank you in particular for allowing me to escape 6+ inches of snow in Minneapolis. My wife has to deal with it though. So I'm going to talk about the technology end of smart cities in a way, but not just that. And in fact, as we go through my presentation, I'll sort of end up moving more toward what else should we be thinking about and what does technology connect with and couple with. So if we can go to the next slide. I don't know, do I have a...
I think, yep, that's you.
So I just thought I'd give you a little sense of my background before getting into the content of the talk. I'm at the University of Minnesota now at an organization called the Technological Leadership Institute, where I lead a program in the management of technology. But before that, for 30 years, I was with Honeywell, retiring as a corporate fellow and a global innovation leader for the largest business of the company, and involved in many different technologies as well as application domains. My technical background is in artificial intelligence, control systems. Last few years, I was getting into Internet of Things quite a bit. And on the application side, did a lot of work in various fields, which we are now qualifying with the word smart. So smart grid, smart buildings, smart manufacturing, smart cities in particular. And also some other fields as well. So it's this sort of connection between the technology and research side, starting out in the corporate world, but now in an academic environment, and thinking about how technology relates to the broader context and how does technology impact industry and society. So that's sort of where my head's been at in the last several years. All right, so give you a very brief introduction. There are a couple of facts about urbanization that in a sense have been referred to, but I do like to highlight in talks on smart cities that I give. And then talk about technologies and also about the market. So as was referred to, it's not just that we're developing technologies for smart cities, we're at the point of deploying them as well. So I wanted to talk about those. I have this sort of, another thing I like to highlight in talks and presentations on smart cities I give is that smart cities needs to be more than just work on smart energy or smart buildings or smart transportation or smart Y. Somehow it has to come together as an integrative discipline. Otherwise, we already have disciplines for many of these other fields. So just give you a couple of examples of how that would work. And then some personal perspectives, trying to put smart cities and smart city technologies in the broader societal context. I was also asked to say a few words about IEEE, and I've been involved with IEEE, as I'm sure some of you have as well. It's a large engineering organization for many years. And what is IEEE doing in smart cities? And you heard a definition about what some parts of IEEE think of as smart cities. So I just have got a few slides from a couple of the leaders of the Smart City Initiative and IEEE, and I thought I'd present some of those too. Okay. All right, so to start with, this chart on the top right is hard to read, of course, but you can see the trend, and that's what's important. Every circle in this chart is a country, okay, and it's recent data. The horizontal axis is GDP per capita, and it goes from, it's a logarithmic scale, it goes from about $1,000 per year to $100,000 per year. So that's the horizontal axis. And the vertical axis is the share of the population in that country that's living in urban areas. And the clear trend is that as countries become more urbanized, they become more prosperous, or conversely, we don't really know the causality. So at least in terms of and being able to relate the two, whether it's one way or the other, it's not clear, but nonetheless, this bottom line here, urbanization seems to be integral to economic growth. So as long as we want to live in more prosperous times, globally, we can expect to continue to see more urbanization. And you can see that second bullet, how this has changed. In 1910, 10% of the population of the world lived in urban areas. A switchover point happened about 10 years ago now. 50% or more than half of the world is now living in urban areas, and the projections for 2050 are something like 68 to 75%, depending on whom you ask, will be in urban areas. Okay? And of course, what that means is that we have to address challenges that come with more and more people in larger and larger cities. The chart at the bottom right, by the way, each of those vertical bars shows the population growth globally in 5 year increments. So the first increment is 1950 to 55, and it goes up to 2045 to 2050. That's the bar on the furthest right. And then the three colors represent different demographics. So the bottom part of the bottom bar, the brown bar, shows population change in rural areas. The large blue bar is population change in urban areas in low and middle income countries. And then the short bar, the yellowish bar, is a mustard bar, is just population growth in urban areas in developed economies. So you can see quite clearly, and this again, there's a switchover point there that's happened, which is that populations in rural areas are now, in fact, decreasing. It's not just that they're not growing as fast as population in urban areas. Populations in rural areas globally are decreasing. And the largest factor of the growth, of course, as you can see, is developing economies and poorer countries. So what this means in some ways is we're seeing lots of challenges and lots of trends that are few of which are positive. So CO2 levels continue to go up. We continue to get warmer and warmer years. Not that that's necessarily a completely linear phenomenon. We're now having snow in Minneapolis regularly in April, which, we've always had some snow in April, but it used to be that the snowiest months were February and March, and now last year we got 20 inches in April, and we've got something like 15 inches already this year too. Water is another big issue. Countries like India, for example, water tables are decreasing, particularly in those areas where there's a lot of urban population, so the Punjab and the Bengal aspects there. Traffic, of course, so this is a report on the bottom right-hand corner here about what it's costing the US. Something like over $1,300 per person per year is the cost of congestion in the US on average. Yeah. So you look at all these problems, and of course we want to deal with them. And if you're a technologist, as kind of I've been in my life, you think, well, we know all that we're doing all these things now. We're developing all these exciting technical areas. There's research going on, and there's a whole number of these, and some of these were alluded to previously as well. So I'm not sure I'm going to go through all of these, but to highlight a few. Pervasive sensing, right? We can have sensors everywhere now, and the kinds of sensors that we can have everywhere and that we are starting to see everywhere include cameras, right? So cameras just widespread in municipal areas, serving lots of purposes, hopefully many good, but in some cases you could question those as well. This notion about having computing at the edge coupled together with cloud platforms. So yes, there's a lot of data being generated. It's being communicated to cloud platforms where there are advanced analytics and algorithms running and machine learning happening. But then there's also actions and analysis and processing happening down at leaf nodes as well. So smart cameras or smart traffic lights or smart devices of other sorts that are making actions autonomously based on data that's collected and then the data that's processed, right? We heard about 5G. So people are looking at 5G, among other things, for really shortening latencies in communication. So now when you think about, okay, well, there's data being generated at sensors of various sorts. It's going up to the cloud. It's being processed. Of course, we have fast computers. Well, then it has to get back to some place where some action might be taken. You do it through conventional communication technologies and through the conventional internet. There is very little reliability in the latency, in the jitter of that communication. It's hard to predict how long it'll take for that round-trip signal. Well, with 5G and with the next generation internet, the idea is that now we have the tactile internet, right? So tactile internet means that within something like 100 milliseconds, you could get an action back from data that's been collected in one place and action back in the other place, and automatic loops can be closed. So that's one of the visions that in the technical community, and I'm a controls person. One of the hats I've often worn is as a control engineer and scientist, and so we cut our teeth and we like to think that we'll solve all the world's problems by closing loops, right? So here's a great opportunity if you're coming at it from that sort of perspective on closing the loop. And this term, cyber-physical systems, that's something that's gaining a fair amount of currency as well. So think of it this way, right? I mean, there is a city, there's all the physical infrastructure, all the physical aspects of a city. But then there's the cyber infrastructure, all these sensors, all these communication mechanisms, all these computing and storage platforms, all these actuators that are connected, right? So it's the integration of the embedding, you could say, of the physical world in this larger cyber world that creates cyber-physical systems, and that we are seeing more and more across our infrastructures and societies. Okay. So that's, but it's not just about technology, right? And as was said earlier, we are starting. There are markets now developing in these areas too. So we have companies who are selling products under these labels of smart city or elements of smart city. So this is from a report from Frost & Sullivan from a couple of years ago. And it's projecting the global market for smart city in 2025. Right? So this is a little bit into the future, and I'll show you some examples also of what's happening today too in a particular area. But nonetheless, it's certainly not starting from zero today. They're in fact showing CAGRs from 2012 through 2025 too, so you can see the growth rates too. So the largest block here is smart governance and smart security, which by 2025 is projected to be over $1 trillion in terms of market value, with a pretty healthy 10% plus compound annual growth rate. And then smart energy is a really big deal as well, and various other sectors too. So this is what's driving certainly a lot of the research too, but it's also driving a lot of the interest, whether it's here, whether it's in China, whether it's somewhere else. So I just thought I'd show you a few examples of what's happening, in particular in this largest segment here. And again, these were alluded to. Too much of my thunder was stolen by Sam, but perhaps I'll pay it forward for future speakers. So security and surveillance in China. So 200 plus million surveillance cameras installed across China, and they're integrated with face recognition systems. In fact, the idea is that and they're pretty close to that now, virtually every adult citizen in the country has their mugshot in their automated system, and they have this face recognition technology that's detecting people as they go about their businesses, and it's happening. So this is happening today. These are actual pictures from China. Skynet is this system that one company has developed that's now deployed at intersections. People's faces are recognized, and in some cases their names are then flashed onto large displays, just as a way of shaming them if they're jaywalking. So that's maybe the most benign way you can think of using this information, but there's much more to it than that too. But it's not just China, and this is a quote from the South China Morning Post. NYPD is monitoring systems using cameras and facial recognition software developed in China, and this is identical to that Skynet system that you see there, right? So we're seeing it happen. I was, of course, many of you, I'm sure, have been to China many times. I was talking to one friend a few years ago, and he was asking me, so what's Shanghai like? Because I'd just come back from Shanghai, and I said, well, Shanghai is like a bigger, richer, cleaner, safer version of New York City. And he said, who needs that? So I thought I'd mention a few things happening in other parts of the world too, also in this security surveillance area. I'm originally from Pakistan. I was in fact there just last month. And here's something from Pakistan about this National Database and Registration Authority that's working with Huawei to implement the first smart city projects there in 3 or 4 cities now. Not at the scale of millions or hundreds of millions of cameras, but starting out at the scale of thousands. And again, integrating with biometrics and integrating with facial recognition technology. The other two examples are actually from Honeywell. So these are US companies that are doing this work. So my former employer, and I sort of reached out to some people I know there saying, hey, what are you doing in smart cities? And what I got back, and when I was there 3-4 years ago, we were doing a lot of work in smart cities, mostly under headings of smart buildings and smart energy. And now the largest market is smart security, and the second market for Honeywell is smart energy or smart buildings now. So in India, there are a number of smart city initiatives, all with cameras being installed very, very broadly. In Egypt, Egypt's new capital is being envisioned, and again, 6,000 internet protocol cameras to be installed there with face recognition and other things. So it's happening, it's real. Question is, how much further is it going to go? Where is it going to happen? What oversight is going to be placed on some of these developments? Right? So I talked about smart cities as kind of this compilation or collection or an umbrella term even for different vertical domains. But as I was alluding to earlier, I feel that if really it's going to be a technical discipline in its own right, we have to think more deeply about the interconnections between these domains. It's not like these are independent areas. Energy use and transportation, water and power, there's very strong connections between them, and that's where a true discipline of smart cities, I think, can really emerge. So just to give you a couple of examples. So as we try to have more and more power generation from renewable sources, and we have to deal with the intermittency of renewables, it becomes more and more important to be able to forecast and to some extent control power consumption in buildings and homes, right? And a particular issue is ramp rates during rush hour times in the morning and in the evening. Well, what if you had better ways of predicting traffic flows and where people will be at what time? You could make a significant difference in how accurately you predict energy consumption in buildings, in homes, during the mornings, during the evenings, and just by better analyzing traffic patterns and having a sense of where people are going when and how long is it going to take for them to get there. So there's an example of a strong connection between, you could say, smart buildings and smart transportation and smart energy. Electric vehicles as mobile power sources and things, especially if we think about autonomous vehicles, although I'll have to say I'm really quite skeptical personally that we'll ever have autonomous vehicles driving streets of at least Minneapolis in April, but who knows. But think about disasters when they happen, natural disasters or other disasters, and you are out without power in some places. I've been out without power in Minneapolis some years ago after a storm for 5 days. I've never have experienced that long a power outage anywhere else I've lived in the world, right? And if you had electric vehicles, they can also be, they're not just the energy stores as well. They're not just something to be used for transportation. So they can actually be mobile power sources as well. So that's an interesting connection that can be pursued. Energy, water, something like 30 to 40% of the expenditure for municipal governments is for water, for drinking water and wastewater treatment. Right? So that's how much is being spent on that. And a significant portion of overall energy use in cities is just for water supplies. And we've talked about surveillance and security and lots of connections there too. All right, so let's just move to beyond talking about technology. So I showed you this picture and I told you how I'm a controls person and we're going to close the loop around everything, and things are going to happen in milliseconds through 5G and next generation internet and artificial intelligence. And what we tend to forget sometimes in our hubris is that, you know, it's not just about the physical infrastructure and controlling that through our technologies. There are people involved too. And so there's this notion that, and I'm part of a group that's organizing conferences in this topic, that instead of talking about cyber-physical systems, we need to be talking about human cyber-physical systems. We need to understand that people are part of the picture as well. And there is no way really that we will be able to fully automate and make autonomous systems for any sort of domain or phenomenon where people are really embedded in some significant way there, right? I mean, the reason we can automate things so well and close the loop and airplanes that fly themselves or oil refineries or even controlling energy in buildings, a lot of that happens without any personal oversight. The reason we can do that is we can mathematically characterize these domains. We have very good mathematical models of how airplanes fly, right? We develop them in wind tunnels. We develop them through an understanding of the physics. Chemical plants, right? We developed detailed mathematical models of those. Well, we are not at the point, and I don't foresee us being at the point in decades even, of having that level of representation and rigor behind how people behave and human organizations behave. So I think there's some hubris in trying to close the loop for all of these systems. Again, referred to earlier, this notion that we need to balance priorities, that on the one hand, through the use of all of these technologies, we can have securer worlds, we can have environments that are cleaner and safer, we can have a more sustainable ecosystem, right? But at the same time, we have personal freedoms, we have privacy and fairness and justice and these other things that we hold very dear. And if we do things right, I think we can have both. And I think if we don't do things right, we can have neither as well. It's not just that one goes over the other, but both of those could well be compromised. This is a chart I use, or a version of a chart I use in our program to emphasize how management of technology and innovation needs to be about more than technology. That technology is one piece. And if you're a technologist, if you come from a science or engineering or technical background, you tend to think, and I remember, after getting my PhD in artificial intelligence and going to work at Honeywell, and for the first 5 years, my mind was always, hey, I know this really cool stuff, and here's something that I can make work with this stuff, and let's go out and make products and sell it everywhere. And the business was saying, really, all you've done is showing me some simulations. You expect me to make a product out of that, right? So it's not just what's possible with technology. You also have to think about what's desirable to users. Are there customers out there? And even that's not enough. You have to think about, if you're in a corporate context especially, what's viable in the market? Can you actually sell it for a price point that somebody is willing to buy it even if they want it, right? And then there's this other bubble that we should also be thinking about. Should we be developing some of these technologies and products and offering some of these services, even if we can do it, even if we can make money from it, even if there are some customers out there who might be willing to buy it? Is it ethically, morally right for us to do that as well? So that's the other piece that I think is important. Okay, so I probably have a couple of more minutes. Let me quickly go over some slides from IEEE, because as I was asked to talk a little bit about what IEEE is doing. So IEEE is, I think they call themselves the world's largest technical or engineering organization, something like 450,000 members now. And they're structured in technical communities, which are called societies and technical councils. There are about 40 of those. Control Systems Society is one of those. I was the president of IEEE Control Systems Society many years ago. Joe, you said you were president of the National Oceanic OES in the society. So they have these multiple societies. And then when new developments happen, they have a way to spawn activities in those. So in the area of smart cities, IEEE has started a smart city initiative. It's about 7-8 years old now, in fact. Okay. So this brings together multiple societies trying to find what's common between them and how can things be taken forward. So here's the mission of IEEE Smart Cities: to be recognized as the authoritative voice and leading source of credible technical information and educational content, right? And you can see the partners listed there. So these are societies of IEEE that are leading the charge in this initiative. The logo on the bottom right-hand corner is Control Systems Society. That's the one that I'm most associated with, and the one next to it in the middle of the bottom chart is the Power and Energy Society, which is also a big player here, and then Communication Society, ComSoc, too. There's some others too, as you can see. So here's another slide from IEEE. So this is how they think, one of the ways they've been talking about smart cities. So again, it's connecting what they refer to as functional domains with with application domains, you might call them. So in the functional domains are things like sensors and communication networks and cybersecurity and analytics and artificial intelligence and control systems, right? So again, the same technologies, and they're enabling applications in areas such as smart water, smart health, mobility, energy, food and agriculture, smart waste. A lot of what this initiative does, as many IEEE initiatives do, is sort of organize conferences and events. So their next major conference is in Casablanca in October, and they have one coming up in Chicago next year. And then there are various other workshops and events going on all the time. In a couple of weeks, I'm going to Istanbul for a smart city meeting that IEEE is a co-organizer of. One other activity that IEEE does is they're a big standards organization. So standards in communications in particular, but many other fields as well. So they have a standards activity going on specifically for smart cities. So smart city standards for planning, architecture, and deployment. Looking at security, looking at mobility, looking at communication protocols. And then they have some resources as well, and I think I have a chart showing on one of the slide on their resource center where you can access various white papers and see what the events are coming up, get the latest update on the standards activity, etc. And then one other thing to note here, when IEEE started its Smart Cities initiative, and I remember being in meetings then, there was a pretty strong emphasis on recruiting cities around the world to partner with IEEE in this initiative. And they identified two kinds of cities, one they called core cities and one affiliated cities. And the idea was that they would find partners in these cities or maybe partners elsewhere that would provide some funding and some support to start developing applications and projects in all of these cities. They still have these cities identified, but they haven't actually had a lot of success in taking that forward. So they're still very interested in NGOs maybe, or foundations, or even cities themselves providing some support so that they can proceed with some of this vision about creating these technologies and applications that serve the citizens of those cities. And you can see a list of the cities there all around the world, as you can see. Okay. All right, just to conclude with, so I've gone through a lot of stuff with just a summary. So I started by talking about the connection between economic growth and urbanization, the fact that it's seems to be an imperative that as we grow economically, we'll become more urban and vice versa too, and what that leads to many sustainability challenges that need to be addressed. We have all this technology that's available now, and more and more new stuff is happening faster and faster, and in a way there's a lot that can be done with this technology, and it's very easy to think about, hey, we have all these technologies, we'll solve all of these problems. Many of these applications and much of the interest, especially in the corporate context, is happening in these vertical domains. So products and services are being offered in smart security, for example, or smart buildings, or smart energy, smart water. But from a research point of view, I'm particularly eager to see more work going on in kind of interconnecting these domains. Overcoming technological hubris, I've said a few words about that, and then just concluded with my mentioning IEEE Smart Cities, which is really a resource to go to for more information about many aspects of smart cities, particularly from the technological side. Right? So thank you very much. I don't know if you have time for questions, but pleasure to have been here.